All right, so we're going to continue with our discussion of atoms. And um, atoms, when we look at a very simple atom, and this will be something I'll mention a little bit later on, we'll talk about how they consist of primarily three different subatomic particles. And there's one of those subatomic particles that's called a proton. And it's found in the nucleus and it's positively charged. We'll talk about that in a minute. But what I'm going to talk about now is the number of protons that are in the center of every atom determines its identity. And so we said all matter is composed of atoms, and atoms are going to consist, the elements in any given atom, the atoms that are found in any given element are all going to have the same number of protons, because we said what determines the identity of an atom is the number of protons. And so what we're really saying is what determines the identity of an element is the number of protons in each of their atoms. And I just mentioned that we'll come back to this, that protons are one of the three basic subatomic particles that are found in an atom. Now, what is the significance of these subatomic particles and the number of protons? Who cares, right? What is significant is it gives the atom a certain behavior. The way that certain elements act, the way that all elements act, is determined by these subatomic particles, and that's why we talk about them. So elements are going to have distinct properties, which means that they're going to react or not react based on what they're made of, the subatomic particles that they are composed of. So when in the early days, and I'm going to look to see exactly when it was. So in the 1800s, there was this Russian guy, Mendeleev, and he was looking at elements, and people were trying to figure out, okay, we have all of these different materials out here, matter, anything that takes up space and has mass, and they were trying to figure out how do we organize this? How do we understand the world around us? And so he started looking at the properties of elements and how they either react or how they behave, basically. And he came up with a chart, a table. It's called the periodic table of elements, and it's on page 10 in your textbook. And what it does is it's a way of organizing all of these different elements based on how they behave. And so I want you to take a glance at that periodic table. And when you look at that periodic table, and it's on in your textbook, page 10 in your textbook, and here you can see it. When you look at it, you'll see we have there's a bunch of squares. It's made up of a whole lot of squares. And in each one of those squares, there is a one or two letter abbreviation that stands for each of these different elements. And if you look at this thing carefully, we're looking on page 10 and we're looking at the pretty colors of the periodic table. Okay. We're looking at the colors, and you can see there's a whole lot of green, sort of a greenish color. Those are the metals. And then we have this really beautiful light blue. Those are the non-metals. And then in between, we have sort of a pinky, tannish color. Those are the metalloids. Those are going to be important for that cell phone. So he organized these, and so we said metals, they behave one way, and non-metals behave another way in general. And then we have these in between, these transition elements. They're a little bit like a metal and a little bit like a non-metal. And so we'll be coming back to that. We'll be coming back to that. So before we get into all that end of it, we're going to say in nature, we have 118 elements, but some of these elements are sort of laboratory creations. So when we look at what you find out there, I'm pointing out my window out there. When you look at what you find out there and in here and everywhere around us, what you find is that there's 90 different naturally occurring elements. And of those 90 naturally occurring elements, most of them are solid at room temperature. So most all of them, all but 13 of the 90, are going to be solid at room temperature. And then we have 11 that are gas and 2 that are liquid. So again, we're going back to states of matter. And so we have solid, gas, and liquid. Okay, this is lecture number 2.